Hello, welcome everyone. So we're giving persons a few more minutes to join. So get yourself comfortable because we're hoping that we're going to have a really great session this evening as we unveil some more AI tools. So sit tight, start in a few. Okay. Hi everyone, welcome to our second AI workshop for the year 2023. I hope you guys have been, staying connected with us, because as we've said before, these workshops are actually in preparation for the major event coming up, which will be the UA Hackathon. All right, just a second. Second, please, while we bring up the slides. So, as you guys, already know, we are Jamaican developers community, and what really brought us here was passion. So we recognize that there's a need for, building and marketing our skills, and an opportunity to learn and share knowledge among our colleagues, among like-minded persons, and an opportunity to collaborate and create valuable solutions. So we do see where, there's some sites that are created, for example, and they're not necessarily up to standard. And we see where, if it is that we collaborate better, we can have greater solutions out there. We can solve problems a little better. So that's essentially who we are, like-minded, creative, hopefully problem solvers. All right, so we're happy to have each and every one of you collaborating with us. All right, so these are our tech communities in Jamaica. So for some of them you may be familiar with, for some of them you may not necessarily be familiar with, but this is an opportunity for us, of course, to gather, to build and to grow together. So we see communities like Python Jamaica, Caribbean Girls Hack. So depending on where you are, what it is that you're interested in, definitely have various communities that you can be a part of. Even us, developers, the Jamaican developers community, and we even have Jamaica Artificial Intelligence Association. So there is a community for everyone, an opportunity for you to grow your skills, an opportunity for you to grow, to learn and connect with like-minded persons. Okay, so here is what we have on our agenda. So the next event, actually, it was going to be September 5th. So that's next week, where we're going to be looking at GitHub of AI. And our presenter is going to be Dimitri Johnson. So that's going to be another exciting event for us to learn more about AI and how it is that we can apply it. And of course, bring meaningful solutions to solve our problems. Because, as we saw from last week's presentation, I'm hoping you guys got it, but we saw where AI was actually able to see an image and classify the image based on what it saw. So we were able to code or instruct a computer to view this image and, essentially classify it based on what damages took place to this crop, to this leaf. So even though the solution was geared towards that, we can definitely see where you could actually use the same solution to identify fraudulent passport. So you could actually be using the immigration system. We could actually use it in the banking system to identify fraudulent money. So, essentially, this is a solution where we can allow train a computer to see and understand image. So that was last week. So if you miss it, then always check it out on the YouTube channel. The next event that actually will be coming up, and we'll be sharing the post at the end of it, is giving you some more details around the design competition. Yes, I said it, a design competition. We'll be having a design competition, and the closing date will actually be the 31st, sorry, of this month. So more information we'll be sharing more information at the end. And apart from that, the AI hackathon, the UA, so far we're scheduling it for the September 23rd, and we're hoping that after all of these workshops, you will get enough knowledge to build AI solutions to solve your problems. or solve the problems that we have or you've identified. So without further ado, we're going to go into our presentation with Sammarieo Brown. Right, so this is Sammarieo Brown. I hope you guys will make him well. You can see he is very proficient in the area of technology, right? He is one of the leading, he's working at one of the leading digital transformation agency, Pixel Perfect. So I'm sure there's going to be a lot of knowledge and expertise that has brought him to this forum to be able to share his knowledge and his experience, and an opportunity for us to learn a little bit more about him and how he's used technology so far. So guys, make him welcome. And without further ado, I'd like to hand over now to Sammarieo. Sammarieo, are you ready?
Good. Hi everyone, how is everyone doing? Hope everyone had a fantastic day. As you've learned, yes, I'm Sammarieo Brown, and today I'm going to talk about how leading experts are using applied data science and machine learning AI in the world of investment. And by the end of this presentation, you'll be equipped as well with the fundamental understanding and intuition of what you can go about designing your own investment strategies, systems in place, especially if you are someone who dabbles in the world of investments and trading like myself. So that's pretty much what we're talking about: applied data science and financial machine learning. As Aldi mentioned, I am a data and machine learning engineer. So I do data engineering, machine learning, data science right across the board at Pixel Perfect and other institutions. So just a little bit more about myself. I'm the founder of Alpha Quant's Capital Investment Technologies, which is a startup that focuses predominantly on researching, developing, and implementing quantitative investment strategies. And that's pretty much what I do. Professionally, I am a data and machine learning engineer, as I mentioned. And in terms of education, I did a double major in computer science and statistics at UAE. I'm currently pursuing my master's in applied data science. I have a passion for, like I said, investments. And so computing investments, those are my two main areas. And I always seek a way how I can merge the two. So that brings us to my particular research interest, quantum finance theory. I wrote an article about this a few weeks ago. You can check it out on my LinkedIn, where I talk about how we can model, use principles from quantum mechanics in investments, for example, the uncertainty principles, a lot of different components or principles that we see in quantum mechanics and at the subatomic level, how those transfer into different industries, for example, quantum computing and investments. And then what I represented as well today, regime switching modeling using financial machine learning. That's pretty much about me. So let's talk about the agenda and what we'll be discussing today. So I'll be introducing data science and algorithmic trading, and the fundamental, build some intuition into how we can use data to fuel our investment decisions and make data strategies. They'll be talking about algorithms. Get started. We're discussing backtesting, one of the most important aspects of developing any strategies or investment decision strategy models. We need to backtest them. So we're talking about the importance, pitfalls, and certain metrics that we look at, certain metrics that I personally look at when I'm developing my strategy. We're talking about how you can go from generating an idea to actually deploying that idea. So step-by-step guideline or blueprint, how you can do this. And then I'll be talking about machine learning finance and applications, particularly the applications that are now in the market, what persons are doing. So we'll sharing about that, and then two demos. So one to give you some understanding of how to get started, and then I'll be focusing on my area of research, a very exciting part. So definitely you want to stay to the last one, it's going to shock you. So I believe this one is going to be the real one that you're excited about. So I'm talking about that, and without further, let's get started. So just give me a sec, let me hide this. Yeah, so it's talking about data science and algorithmic trading, right? And when you think about data science, you think about analyzing large chunks of data. And in the financial world, we have trillions of every single day. We're working with a lot of data. And we need to be able to make action-driven. All these data coming in, how can you benefit and profit from these information? Whether it's financial news, whether it's stock price, whether it's economic indicators, sentiment, all these things we can make generate insights from. Really, the fusion of data science and algorithmic trading comes from a form of data-driven trading models. And these models leverage large data sets to uncover patterns, trends, and correlations in the financial market. So by analyzing or applying statistical and machine learning methods to these patterns, we can, one, predict market movements with greater accuracy. We can optimize trading strategies to enhance the returns, and we can reduce the risk of substantial losses from more informed decisions. One of the most important parts of investing overall is managing risk, being able to maximize your return and manage risk. So those are some areas where we use data science to leverage data science in algorithmic trading. So how can you get started with algorithmic trading, or algo trading for short? Well, here are one of the tools that I use. So like I said, the technological landscape for algorithmic trading has grown immensely. We have a lot of tools catering from beginners to even experts. And these tools that I mentioned are tools that I use on a day-to-day basis, and these are the most notable and popular tools, have a lot of community around them, easy to get started. First one is Quantopian, and this is an online platform that provides educational content space for developing and testing and refining your quantitative strategies and algorithms. A lot of persons, especially if you trade Forex, you'll be familiar with MetaTrader. A lot of persons use this. So we use MetaTrader for Forex trading, CDFs or CFDs. It allows for creating, testing your strategies and implementing automated trading models. It has a Python SDK, so it's easy to get started. And then in terms of languages and libraries, the most popular language that a lot of persons use is Python. Definitely the go-to, easiest to learn, easiest to implement. There are a few other libraries in Python like Backtrader that we use for backtesting and simulating. And we'll talk about backtesting a little bit more. Zipline for algorithm trading simulation, and technical analysis we use Talib. In terms of language, a lot of other persons use, especially in the at the institutional level, like big hedge funds, they use programming languages like C# or C++. Provides a more robust, and it's quite fast. Use those languages quite fast, especially for use cases where orders, you want to send in orders and receive orders by the nanosecond. So you want languages that are capable of doing that sort of high frequency trading. But for the larger case, we mostly use Python. And then I see some persons use R. You're familiar with R as a statistical tool. So getting started, right? So before you can get started with algo trading, you must have some level of understanding of the financial market and how the financial market works. And while I mentioned a lot of those tools, it's essential to build a fundamental understanding of finance because it's crucial to successful algorithmic trading. So one, you need to have an understanding of financial literacy, which really helps in understanding market dynamics, how the market moves, understanding financial instruments, the different type of instruments like stocks, crypto, foreign exchange, commodities, future. A lot of these instruments exist, how they work, what factors influence these instruments, economic indicators like GDP, interest rate, and how they can influence your trading strategies and certain assets. So having a fundamental understanding at this level gives you the opportunity and the information and knowledge to go about building these systems. Right? You must have understanding of risk management. Like I said, risk management is very crucial, and knowledge of financial principles aids in better risk assessment and management, preventing large-scale losses. The aim of investing is to maximize the returns. You don't want to be investing at the same time you're losing money. It is a large. So it's important to have some understanding, a great level of understanding about risk management. Regulatory awareness, you must be in regulations, trading rules, compliance, for example, inside the trading and certain assets you can trade, that kind of thing, and strategy refinement. So deep financial insight in how you can enhance your strategy creation and developing markets or strategies that will work in real-world market conditions. So to recap, you must have some level of domain knowledge in finance. So it's easy. YouTube is there. Google, you can simply just go ahead and one Google search and information on what you need to know about certain aspects, the market, books, YouTube, and that kind of thing. So I just gave a brief idea of what algorithmic trading is, how we use data science and algo trading, and how you need to get started. Now, I'll be talking about backtesting and why it's important, right? So backtesting really, in a nutshell, gives you the ability to develop a hypothesis or some idea and be able to test it on historical data in the past, right? So it's a simulation technique where traders test strategies or models using historical data, and by applying strategies to past market data, traders can assess how the approach would have informed or performed during the specific period, right? And it serves as a retrospective analysis to gauge a strategy's viability. It gives you some confidence to know, well, is my strategy worth actually investing, right? So idea, you don't want to use your life funds, so you actually really want to test whether or not you're going to be successful. Lot of money in that case. So backtesting provides a framework to test your hypothesis or your idea on a certain instrument in a certain time frame, maybe 10 years worth of data. You can test the idea, whatever idea you develop. So this is important because it gives you performance insights into how your strategy performs without any financial risk of losing your own money. You can be able to tweak your strategy, improve it, gives you confidence to know whether or not your strategy is going to work, allows you to manage risk and validate your strategy. So what are some pitfalls of backtesting? Well, one of the major pitfalls is what we call overfitting, where you fit your strategy too closely to past data and makes it ineffective for future scenarios. This is very popular in algorithmic trading, machine learning. It's a major problem, right? So overfitting is one. Look ahead bias, where you accidentally or sometimes intentionally use future data in the backtesting, and it gives unrealistic, optimistic results. So we call it survivorship bias, which is really you're testing a particular asset or stock that has survived or remains successful, leading to some sort of skewness in the data, and it gives you misinformation. So those are some pitfalls or negative effects that happen to traders when they're backtesting their strategy. And then what are some metrics that we look at? So you need to find a way how you can quantitatively assess how your strategy performs. And there are a lot of metrics. The amount of metrics that exist, one screen can't fit the number of metrics. I will show you an example in a few minutes. But I think these are the top metrics that we should look at, and that I personally look at. One, Sharpe ratio, which measures your risk to reward, so how much you're risking versus the return. So a higher ratio provides a better indication of risk-adjusted return, shows that your strategy is performing well. There is maximum drawdown, which, as the name suggests, the total loss that your strategy will have occurred for your portfolio over a period of time. And the smaller this number, the better your strategy performs. Then there's a Kalmar ratio, which is pretty much similar to the Sharpe ratio, except it looks at the annualized return versus the maximum drawdown. And again, a higher ratio is better, similar to the Sharpe ratio. There's also the annualized return, so it gives you an idea of the yearly performance of your strategy and what you're expected to get annually. There are other metrics like win rates, your loss rates, and how likely are you to have consecutive losses, consecutive wins for a particular strategy, and that kind of thing. It gives you solid and concrete information into your strategy performance. So you learned about backtesting, you learned about applying data principles to investments and creating your own algorithm. Now, how do you really get started? So I created a 5-step framework that anyone can follow and develop their own strategy. So before we can create a strategy, really creating your strategy is not a spontaneous process, but it's rather a systematic journey, as I mentioned here. So from the initial spark to the real approach, there's a step-by-step breakdown that ensures that your strategy is profitable and robust in diverse market conditions. All right, so let's look at the chart that we have here. The number one thing that we need to do is to come up with an idea, of course. Right? We need to come up with some form of hypothesis that we need to test. For example, very simple example, I realized one day while looking at the markets, I realized I was looking at the Dow Jones Index, or what we call US 30. Basically, 30 stocks pulled together in the US market, right? And I realized that every 8 to 9 o'clock, the market tends to shoot up price, a lot of volatility, high volatility. And so that's an idea. I went back and I tested this on a few days, few months, and realized, well, this idea tends to hold. What you shouldn't do after getting that idea is, oh, okay, this seems pattern. Every 8 o'clock, I'm going to buy the US 30. I'm definitely going to lose money without some certainty that this actually holds. So before we go about diving into the market from just identifying some pattern, because the brain is trained to identify a pattern, and sometimes what we identify as pattern is not really a pattern, but just bias or own bias, right? So from you generate your idea, then you have to go into collecting the data. That's the second step, the data collection. So if you're looking at news, you get your news, financial news data, economic data, depending on the strategy or the hypothesis that you are formulating. For example, I just mentioned buying the US 30 every morning at 8 o'clock. Well, first thing we need to do is to collect data, historical data. So maybe we can collect data from 2010 to the present day and test that. So normally, just between these two steps, before developing your strategy and after doing your data collection, you want to do some data validation, clean your data, ensure that your data is clean, it's prepped, it's ready for modeling, right? Do some statistical analysis, find some pattern, analyze some trend, and that sort of thing. And then now you're going to actually developing your strategy. So designing and building your trading model from the initial idea that you had. And this sometimes involves some technical indicators, statistical model, or even machine learning, especially if you want to predict the price, movement, or that kind of thing. And then from you develop your strategy, you move into backtesting. So you test your strategy on historical data. And this step gauges its theoretical performance and helps you to identify potential pitfalls. And you're able to even tweak your strategy. Then after this, we have the optimization phase where we refine the best parameters. So given that we say we're going to buy the US 30 every 8 o'clock, well, time is now a parameter. So we're looking at time as a parameter, right? I think with algorithmic trading, and one of the pitfalls is that, especially if you have fixed parameters, we tend to have a decay over time. Sometimes these parameters don't really work. It might work for a period of time, and then after that, it doesn't work again. You're probably wondering why your strategy is profitable, because that parameter no longer holds. For example, maybe it stops going up at 8 o'clock and then starts to go down at 8 o'clock, and 10 o'clock, the price goes up again, if you follow me. So we need to optimize the strategy, and we also need to do this in a loop in real time as well. So optimization allows us to refine and enhance the strategy. And this can involve tweaking parameters, adjusting for risk, and incorporating feedback from your backtesting phase. And what I should have probably added here is the sixth phase called deployment, where you'd actually, if your broker has some broker API, you can send orders to your broker exchange to actually process those orders. So you have some system deployed where at 8 o'clock, it starts up and it checks if the condition is met and sends an order to your broker to get the order filled. So that's pretty much how you start from the idea to the deployment phase. And then financial machine learning. So machine learning and AI has found its way in almost every industry today. Major one is in natural language processing, large language models. Lots of companies using large language models, AI in almost every aspect. If you think about transportation, AI is there. If you think about investment, AI, med tech AI, a lot of fields have been incorporating machine learning AI because what it allows you to automatically learn and adapt and improve from experience and find patterns that aren't there and improve the workflow. So in the financial domain where data is abundant and patterns can be subtle, machine learning models provide a robust toolkit to uncover insights, predict market dynamics, and enhance decision-making capabilities, giving you the edge over the market, something that no one else is doing, and you have a certain level of confidence and profitability. So what are some applications of AI investments? Well, we talk about algorithmic trading, and that's probably one of the major areas where we see machine learning. Then there's portfolio optimization. Like I mentioned before, the goal of investment is to maximize your risk, maximize your return and minimize your risk. And using machine learning coupled with portfolio optimization can give you the ability. When we have risk management, assisting you to manage your risk, sentiment analysis, whether you're analyzing financial news, get some sentiment that's positive or negative, fraud detection, asset price prediction, credit scoring, of course, my area regime detection. Right, so we tend to see market move in different states, or we can classify the markets in different states. For example, whether the market's up, the market's down, the market's moving inside it. We can classify these in hidden states or states of the market. So I'll show an example. That's the last thing I'll be doing. How I use financial machine learning to classify the market and predict the state of one market and how it will affect another market. So that's pretty much it for the presentation. So I'll go into the demo. If you have any questions, please feel free to interrupt me. But yeah, that's it. So we'll be talking about the demo, and yeah, so that's pretty. So let's create. So let me know if you can see my screen. Are you able to see my screen well?
Seen it, but could you zoom in a little more?
Sure. Is this better?
Yeah, it's better.
Okay.
Anyone else okay? Everybody else okay? All right, good.
All right, so we're coding Python, so hope you have some level of programming. If you don't, that's fine. I'll explain exactly what I'm doing. See a message in the chat. When it comes to trading AI software situation, what do you do? Well, that you do well enough? Are there any other data you use aside from typical graphs and statistics? Okay. So it depends on the strategy I'm using. Sometimes I use economic data. So if I'm trying to find some correlation between, we see other economic data like in the US, non-farm payroll that has a high impact on how that affects the market. There's also interest rates that you ask, interest rates, GDP, and when the Fed rates interest rates, how this affects the dollar, and when it affects the dollar, how it affects certain other instruments and that kind of thing. And even natural language processing and AI, we see where the Fed tends to have speeches like maybe once every month where it talks about what the plans are and that kind of thing. And while he's talking, the market is sometimes going crazy. What we can do is you can have a model that classify or predict the sentiment of what speaker is saying, and Fed shape over what he's saying, and then you can say, all right, if it's negative, you probably want to go short on the asset. If it's positive, it's saying, okay, the economy is going to boost, we're going to lower interest rates, that kind of thing. It's a positive sentiment. So there are a lot of alternative data that we can use. I mentioned that in another presentation, where data, this company or this investment institution use satellite data, satellite images to analyze oil data to look at, for example, Walmart parking lot. So looking at satellite images to say, all right, when there are a lot of vehicles, a lot of trolleys in the parking lot, it means that, well, a lot of persons are buying, and then we can expect Walmart price to go up, that kind of thing. So there are persons out there using AI and machine learning in some ways, some really crazy ways that they're using to make money. So a lot of alternative data, not only financial news, not only stock price, but much more under the hood that they can use. How do you deal with unpredictability and volatility of financial markets when designing and implementing trading systems? Well, first, you have to understand that the market is inherently unpredictable in some sense. And there are different models you can use to model the volatility. When we talk about one I'm using, the volatility index, and how I can use that. So you just have to develop your strategy in a way where it can account for certain uncertainties in the market, right? You have to understand that your strategy won't always work in certain conditions. You have to know the type of conditions that your strategy will work in. I hope I answered your questions, Angie. So let's get started. The first thing we'll be importing some packages that we're working with. So working with pandas, working with NumPy. So NumPy allows us to do calculations on the data. Pandas allows us to manipulate a data frame. We want to do some visualization, can use Seaborn. I think, yeah, it's Yahoo Finance. So we're getting the data from Yahoo Finance. From Yahoo, that's where we're getting the data from. I think that's it. Let's ignore some warnings and for warnings. All right, so let's also write a function to get our data. So that's the next thing that we need to do. Write a function to get our data. So we're getting the data from Y Finance. So we'll just wrap this in a function. Call this get data. I'm going to pass, symbols. So which symbol we're working with, the start date. And it's going to give this. For now, I believe that's it. All right. So let's get, if we don't pass in an end date, we're gonna just use the today's date as the end date. So that's what we're doing here. Yes. Feel free to ask any questions in the meantime, what I'm doing. Promise to make this session a very engaging session, so feel free to ask any questions. All right, so fetching the data set, let's return this, return data. This is a function to get your data, right? So we're passing a symbol to which asset we want to look at, start date and the end date. And for this session, we'll be working with Apple. So anyone invest in Apple, a lot of persons have Apple products, iPhone, AirPods.
No for me.
A lot of persons that don't use any other products, like Apple is it all the way. But I think Oshi is Windows man.
Yeah, Windows, Linux, Chromebook. I have no Apple products.
Yeah, that's not me though. I mean, Windows have some really good products. I'm using a Windows here, but generally, I'm a fan of Apple products as well. Start date and end date. Oh, that's not passing it end date already. Begin today. All right, so we get our data. So we're getting the data from 2010 to today's date, present. So let's have a look at how our data looks. All right, so data.head. So we can get the first 5 rows of our data. And you can see this is what we're working with. So we're working with the dates as the index open, the high, the low, the close, adjusted, close, volume, and that kind of thing. This is from 2010 when the Apple price was at $6. Let's look at Apple today and the price and how much it has actually increased over time. You can see today the price for Apple closed at over $180. So we can create some features. We mentioned technical analysis. So we can actually create some features. I forgot to import whatever libraries, technical analysis library. We use as TA, stands for technical analysis. So that's what we use to like calculate exponential moving averages, that kind of thing. So let's calculate the return. So we're going to calculate the return of the stock over time first. So that's the first thing we'll look at. Returns. And you first need to calculate the log. And that's why we use NumPy here to calculate the calculations on their data. I input and we input NumPy as NP. So.
Do you find NumPy a better tool than Panda? I personally tend to use Panda.
Pandas?
Yeah.
But I think calculation with NumPy are much faster.
True.
I normally use Pandas to just manipulating whatever, change some columns, handling missing data, that kind of thing. So stuff you probably do in Excel, you would do with Pandas and more.
I see.
So getting the price change over time for the log. All right, and we're going to calculate two metrics. We're going to calculate the long and the short AME. And AME. We're using an indicator here, so we don't have to calculate the data calculation manually. We can just use a package that allows us to do that. We pass in a parameter. So we talk about parameters and why we need to optimize parameters. This is an example of one. So the window for the long AMA is a parameter, and sometimes these parameters can be optimized or just over time. So it's AMA. We pass in a lower window, so we can go on. This is what we're working with now. So let's see what our data looks like. This is no data. So we can see we have some missing values here. So I will probably drop these missing values. So let's get rid of those. Get rid of that. So I get rid of those missing data. And that's a part of the data cleaning process. So now you can see we don't have any missing data working it. So now that we have our data, we're clean and prepared, let's do some exploratory data analysis. So let's visualize what it looks like. So I'll export it up to save time. You can have a look at that. So this is the price over time for Apple, right? You can see it's a bit messy here, a lot of price fluctuation, but as you can see, it's been a constant trend going up. All right, so normally I want to just explore the time series, what a time series looks like, and then what the return distribution looks like. So if this is normal, it means that there's less fluctuation, the price is more centered around the mean, and we can see distribution is somewhat normal. Have some outliers, some skewness, well, not skewness, but a bit outliers. We can see, but generally data is skewed. So these are some visualization that I normally look at. And then when it comes on to time series analysis, let's go back up. Look at the time series. As you can see, it's pretty, it's a word to describe it. It's a lot of fluctuations, and we can smooth out these fluctuations, right? by doing time series decomposition. Just gonna copy this, paste it over here. So we're taking out certain components out of the time series. So we're taking out the trend, so we're smoothing the time series for one. That's what we do here with seasonal decompose. We're passing a certain period. So we are 365 days in a year. But if we want to get technical, we know that there are 252 trading days actually. So we can pass in that. So this will help us with calculating the seasonal composition, the residuals. And yeah, so let's just print this and see what this looks like. So as you can see, we have the original trend, but when you look at the smoother trend, it gives a better idea of the market direction. We look at the seasonality, we see some seasonal patterns, and you can actually develop a strategy from this. You see a certain period in the year, price tends to go up, certain period price tends to go down, and that kind of thing. So you definitely want to do some time series analysis before you actually your data. And then another statistical analysis I love to check for is whether or not my time series is stationary. So if you're predicting your data, you can't really predict non-stationary data. So if the data, it needs to be stationary. So if it's not, you need to do some log transformation or transform my data to make it predictable. And as you can see, my data is already stationary, so I don't really need to do any transformation on that, so that's good. So here is the strategy that we're going to develop. So we're going to move into the strategy development. So we have the short EMA and we have the long EMA, right? And what we're going to do, we're going to say whenever the short EMA crosses the long EMA, we're going to buy. We're going to buy that stock, we're going to buy Apple. And whenever the short EMA goes below the long EMA, we're going to sell. So simple strategy. Let's implement this. So I have the code here. I'm just going to copy it and paste it over here to save you the time. I'll just walk you through it. So I'm going to print this first and to give you a basic idea. So just to remember, we're saying if the short EMA is greater than the long EMA, then we're going to buy. And if the short EMA is less than the long EMA, we're going to sell. That's pretty much the intuition behind it. All right, and every other thing here, we're just plotting the data and allowing it to be visible. So I hope you can see. Let me try to make this bigger. You can see the markers here. The green markers are for the times when you're buying, and the red markers are for when you're going to sell. For example, here's an example where we actually would have bought the asset and price would have increased and we sold here. This strategy is not perfect, but yeah, there's a next area where we would have bought and we would have sold here. So we would have bought at around $70 and would have sold at around 100, a little bit over $120. So the problem with this strategy is that this is a momentum or trend.
Yes, Rob, what are you doing?
So yeah, this is a momentum. We call it a momentum or trending strategy. And what I've realized is that the market operates in states, and that's predominantly what I do my research on, the market operates in states. So we can have a trending strategy where the strategy is going up or it's going, the symbol of the asset is going up or it's going down. So that's two states. However, there's a third state, which we call a mean reverting state. And the thing is, the market tends to move in ranges, right? So for example, here, like just this area, we can see where the market is ranging. So it's not really going up, it's not really going down, it's fluctuating between a certain range. I'll call it a mean reverting state where it deviates from the mean to a certain extent and it reverses back to the mean, and it deviates below the mean, reverse back to the mean. So we call it mean reverting. That's actually a strategy that we can also develop as well. So whenever we have a trending strategy, mean reverting strategy, our market won't work in that sense. But whenever the market is trending, a trending strategy will work for a trending market. So the issue or the problem now is how do we classify the states to know which strategy to deploy in whatever market condition, whatever market state. And that's a real challenge for a lot of persons. But I'll show you how I solve it in a few seconds. So just to recap, we're buying when the price goes above the moving average, we sell when the price goes below the moving average. So that's pretty much the strategy. So let's develop or implement a strategy. So I have a function, I'll walk you through it. So we're implementing backtesting EMA strategy. The initial capital is $10,000. and we accepting the short EMA, long EMA, and we set those. So we have a data frame called strategy. So this is going to be a signal column. So whenever we need to buy, whenever we need to sell, we're going to store it here. If the price goes above the long EMA, well, we're going to put that one as buy. And if it goes below, then we're going to sell and put that as -1. We'll calculate the returns here and get your portfolio value, drop the missing data, set the data, set the day time frame to UTC. And that's it for a strategy. So we're passing in 20 EMA and the 50 EMA. So short window is 20, long window is 50. And let's see what this looks like. So we're going to use this package called QuantStats that allows you to simulate or backtest your algorithm to see what we would perform over time. So that's what we're going to use today. So let's have this run for a while. All right, so let's evaluate the performance of strategy. So we have some metrics here. I mentioned there are a lot of metrics. We can't finish all of them. But the main ones, those are the ones we're looking at. So we're getting data from 2020 to 2023. 94% of the time we're in the market, we're buying. The cumulative return would have been 7.19%, not so much. Ratio wasn't that good either. It's a very low Sharpe ratio. So I wouldn't implement this strategy. But with a lot of optimization that we could make the strategy better. I think I'm going to put it to 2010. So let's run this again. A longer period. And generally, I want to backtest a strategy on no less than 5 years worth of data. I think that would give you a substantial amount of data to test your strategy on. So working from 2010 to today. All right, so yeah, that's it. Overall would have been 16.2% return on the strategy. The ending profit, but there could be better, right? So not really a really perfect or amazing strategy. Your Sharpe ratio is still low, now 0. So we're risking more than our actual return. That's pretty much what the Sharpe ratio is telling us. All right, and the maximum drawdown overall would have lost 18%. This is a maximum drawdown that we're looking at. Your daily return, what it looks like for your daily and annual returns. And so some more metrics that you can look at there on your best day, what would your best return look like for a particular day. So best return for a day would be around 6.53%, your worst year. So this gives you some understanding of how well your strategy is performing. And for me, this is not a profitable strategy that I would implement. And overall, you can see the strategy returns over time, the cumulative strategy returns. So we started off in a loss in 2010. Eventually, we became profitable around 2012, and there are both fluctuations. You can look at a year. Negative drawdown for 2010, 2011, we saw return over 10%, 2013 over a little bit over 10%, and that kind of thing. And look at our distributions return. This is our maximum drawdown points, the drawdown over time. You can see our maximum drawdown was around 2018. That's when we lost the most amount of money. And this is you can look at this for how your strategy perform each month for the number of years that we have backtested strategy on. You can see a lot of losses, profits over, but mostly large losses. Yeah, so that's pretty much how you can go about developing a strategy. Now, we mentioned, so we talk about getting the data, cleaning the data, doing some data exploration analysis, implementing the actual strategy and backtesting it, evaluating the results. And now we have strategy optimization. So how can you optimize the strategy to get the best parameters? All right, so that's what we're going to try and do today. We're going to find the best parameters, but we're using 20 and 50, which might not be the ideal parameters for a strategy. So let's say we implement our algorithm to find the best strategy. And what we're doing, we have a grid parameters or a search space for both the short and long EMA. So from 15, 5, 25, 30 to 75, that's what we're working with. And we're going to try to maximize the Sharpe ratio. So that's the method that we're working with. Maximize return, minimize risk. So if we can have a maximum Sharpe ratio, then we can use the parameters that we get for that maximum Sharpe ratio. And let's see what that looks like. So it's going to run for a minute or much shorter. So our Sharpe ratio, maximum Sharpe ratio rather is 0.4%, 0.4, with EMA being 15 and 45. So let's implement that 15 and 45. That's what it looks like. Capacity 15 and 45. And just let's note before we actually run the strategy what the original performance was. So original performance was 16%, and the Sharpe ratio was 1.8. So let's run this with the optimized parameters. As you can see, a much better performance when you actually optimize the parameters. So cumulative returns look much more stable. Year-over-year returns much more stable, and that kind of thing. So let's look at some other metrics. Now, our cumulative return jumped from 16% to a whopping 49%. So this is the importance of optimizing the strategy. Like parameter optimization is very important. Sharpe ratio increased, and a lot of other metrics. Maximum drawdown decreased. I think the last one was around 18% decrease to negative 13%. So we're losing less and we're gaining more. That's pretty much it for how you go about developing an algorithmic trading strategy, right? And there are a lot more you can do. You can create more features. You can add more parameters to enhance the trading strategy. So that's pretty much it. I hope you learned a lot from that. I'm going to present on the other demo. So pretty much what the code for this already. So we can just discuss the implementation. So you don't have to watch me write the entire code for this. So let's build some intuitions first, so you can get a better understanding of what we're doing. So, there in any stochastic random system, there are different states. There are going to be different states. For example, let's say a weather condition. Weather condition can be classified as a state. Well, it's raining. Three states, for example, rainy, sunny, and partly cloudy. So those are the three states that we're working with. And what we want to know is, are we able to, one, classify the states that we're in, and two, predict the probability of transiting to a next state. So what's the probability of us moving from state A to state B, or from state B to state A, or from state A to state C, or whatever it is? How can we develop a model to predict the different states, right? So if today is rainy, yesterday was sunny, what's the probability of tomorrow being cloudy? Or what's the probability of tomorrow being rainy again? So that's pretty much what we're trying to do. So in the market, we have different states. We have upstate, we have downstate, like I said, we have mean reverting state. So there are a lot of states in the market. It's not only limited to those three, but based off my domain knowledge, I just want to classify with three states: up, down, and whether or not it's mean reverting. So my problem is, how can I classify these states? And that's what we're going to talk about today. So pretty much the same thing that we did, our function to get your data, except we're working with two different symbols. We're working with S&P 500, which is a pool of 500 stocks in the US, right? And it's the safe investment for everyone. Everyone tells you to invest in the S&P 500. It's the safest return investment asset you can get. And then there is the volatility index, which measures how volatile the market is for all these stocks in the US market, right? So let's get their data from 2019. So those are the two assets that we're working with, and we're just going to calculate some metrics. Same thing that we did before. That's the same thing we're doing again, just in a more efficient way. So gathering the data, Doing some exploratory data analysis. So we're working with two symbols. Let's do some time series exploratory data analysis. So let's look at the VIX, call this the VIX, volatility index. And below we have our S&P 500, so we're comparing the closing price. And what you can see is at points where we have, just by looking at this, at points where we have a period of high volatility, we tend to see where the S&P 500 tend to go down in price. For example, we look at this point here, see we have a high level of volatility, right? And how does this influence the S&P 500? Well, as you can see below, price plummeted. And this was in at the beginning of 2020 during COVID time. And this is pretty much the, so just by looking at this as a strategy, I would probably eyeball, but we need to test this and see how profitable this would be. So when I look at some distributions, so in financial analysis, distribution returns really offer key insights to the asset risk and behavior, right? So for our plot, we're working with VIX and S&P 500, and this reveals unique volatility and tendencies of market fluctuations. So we look what questions we're trying to answer. Is the returns normally distributed? So if the distributions are close to normal, it simplifies the risk assessment, and it shows that, well, one, you're not too much to deviate far from the mean, right? And then just real deviations. So that's pretty much what we're looking for in plotting the distributions. So we're going to compare the distribution of the S&P 500 and the VIX. And you can see it's pretty, for the S&P 500, it's pretty normal, but it's a bit skewed for the VIX. So we can see can expect a lot more fluctuations with the volatility index. And I think someone asked about how you model or take into account volatility. This is a symbol you can actually use to model if you're working with US stocks, so you can model the risk in terms of volatility. So we're going to check for some correlation. So we're using the close price, the returns, and the range. Those are the features that we're working with. I'm going to check for some correlation. Well, how do they correlate? So we can see from intuition that we have some level of correlation, but actually, is this true? Right? So looking at the close price, we can see a negative inverse feature between the two, as the close price for S&P 500 goes up, the VIX goes down, and vice versa. So we can actually put those out, and you can see this here. There's a correlation between the two. So just to recap, those are exploratory data analysis. Now we're going to go into actually modeling the state of the market. All right. So we're using the Markov regression model. So we're going to just do some data preparation. We're dropping all the missing values. Missing values, unclean data really messes up your data model, or your model really, so your model doesn't perform as well. So you need to do some cleaning. Really, data is quite clean. What we need to do is just get rid of the missing values. We could also do is to check for skewness. A lot more for the data preparation step. We could check for skewness. We could check for stationarity, autocorrelation. So are these features autocorrelated, multicollinearity? A lot more statistical tests that we could do. For this step, we're going to go simple and just work with dropping the missing data. We reshape our data so model can work with that effectively. And we're creating a model for the VIX and the S&P 500. So we're passing a regime. So we're working with two regimes, up and down. And we're going to pass in lower trend and switching variances. We're going to fit that with our model. Just fit that. And these are parameters. You can see our parameters, the period, the p-values, and the covariance types. Let's look at, well, it's pretty much the same data for S&P 500. But let's print the first and second state regimes. All right, so we calculate the marginal probabilities. We're going to check if it's greater than 5. If it's greater than 5, then we can say, all right, that's the first regime. Other one's greater than 5, second regime. So you can see two regimes here, the up state and the down state. All right, those are the regimes that we're looking at. And let's see how this actually plots on the VIX index. So this is pretty much it. So you can see lower state with a lower probability and higher states, or a second state with a higher probability here. On top of the visualization, I just added this one as a shade. All right, so picture these. Yeah, I think I did this already. Yeah. So this is the creating the strategy now. So we extracted our states from the market. So this is the strategy that we're going to work with, because we know that S&P 500 and the VIX is negatively correlated. If we can know the state of the VIX, then we can know how we can gauge investments from the S&P 500. So if we're in a low state, this is the strategy. If we're in a low volatility state with the VIX index, then we're going to buy the S&P 500. If we're in a high state, we're going to sell the S&P 500. That's pretty much the strategy that we're working with, right? And the same thing that we did before, calculate the returns, create a data column, signal column rather, to store our signal so we can backtest those. And we set our portfolio value to 100,000. So let's see how this performs. Anyone excited to see the results? Or it's actually showing already. No more surprise. All right, so let's look at the first strategy that we had. I'm going to compare the results. So for this EMA strategy, we had, with the best parameters, we had a 49% return. That was what our cumulative returns were for a period of how many years? From 2010 to present, right? Let's look at the strategy returns for this model, this strategy. As you can see, from 2019, a shorter period, we gained 426% return on your money. It's impressive. I mean, if you think that's impressive, that's impressive. I think that's impressive. That's really crazy, right? Like, compare this with any investment institution and what they're offering and what they would promise you. That's nowhere close to 426 in just less than 5 years or 5 years. So that's pretty much it for developing strategy analyzing. As you can see, Sharpe ratio of 1.82 for the Sharpe ratio compared to a 0.41. So what this is saying is that we're making a higher return with minimizing our risk, with risking a smaller portion of the capital per day. And let's actually look at the maximum drawdown. So overall for this would have received a 16% drawdown, which is pretty good compared to the actual cumulative returns that we're getting. All right. Per day, your expected return would have been around 0.5%. Expected monthly return would be 3%. Now let's talk about this. Imagine having a strategy like this and you have 100,000 in the bank and you're investing 100,000 in a strategy like this. Which bank is going to give you 3.19% return monthly on your capital? Right. So this is the benefit of using machine learning and developing algorithmic trading strategies to boost your investments. Right. So a yearly return 39%. So that's really good. All right. Consecutive wins 8. Yeah, 8 consecutive wins. So wins in a row. Consecutive losses 7 actually. And some other metrics that we can look at. And this is our cumulative returns over time. It's pretty steady and increasing over time. All the periods, all the years, we've never had a down year in our strategy. So this is a strategy that we can validate and say, we can implement the strategy. And our drawdown is pretty much minimized. So we have smaller drawdown periods. And if you look at the monthly returns over time, you can see in 2020, when the market was going crazy, and I believe so it's a massive drawdown period, we would have actually made 25% in COVID time. And yeah, that's pretty much it. Hope you enjoyed it. I added something else here to just show when you're actually buying and selling in the market. Let's just rerun this. So you can see when you're actually buying and when you're actually selling. Just a sec. It shouldn't take too long to run, so.
I think you may be pulling too much data this time.
Yeah, exactly. Yeah, it's from 2010. It's from 2010. All right. So here you see. So we bought here and we have sold here. So what we're looking for is periods where we buy, we're expecting to sell at higher periods, and periods where we sell, we're expecting to close at lower periods. Sarah, what's up?
Oh, hi, Sammarieo. Good night. I wanted to ask, so I see where you have within the results the max number of losses, the max number of wins. Does the model take into account where if the max number of losses exceed the max number of wins, like, or is just you personally would have to just interpret that and decide if you're going to use that strategy or not?
I love that question. I love that question so much. That's a good question. Actually, no, the model doesn't. But what you can do, you can set these conditions in place. So this is what risk management is about, right? We can develop risk management tools. So you can look at that now and say, okay, if I have, so this is the importance of backtesting. So your expected number of consecutive losses are around 8. So you can say when you're actually going to deploy your strategy, if they can set a condition to say, if my maximum number of losses exceeds a certain amount, then what I'm going to probably close all the positions, or I'm going to stop the model and I'm not going to trade anymore, or I'm going to whatever condition that you want to make to take into account. All right, so that's the importance of backtesting. So to answer your question, you'd have to manually input a simple code to just write that up, write up a condition to input that.
Okay, cool, thanks.
Yeah, so this is pretty much when we buy and sell in the market. So you see a big Jordan here, so you can see we have sold here and we've bought here. So they've profited in both directions of the market. So whether we're selling or we're buying. Yeah, so that's pretty much it. Hope you learned a lot. So this is my question, is what I do a lot of research and focus on, other than my day-to-day work in school. This is my area of research. So hope you learned something. If you're interested in investments and developing your own strategies, you will have garnered some level of knowledge to actually go there and write your own strategies. There are a lot of resources, a lot of community built around developing your own systems. And the thing is, a lot of large institutions like BlackRock, Bridgewater, Associates, Renaissance Technologies, and major hedge funds and investment banks, especially in the US, this is what they're doing to maximize their returns and generate a lot of profit. As individual investors and as developers, we have the knowledge, because the knowledge that they have and knowledge that we have pretty much the same. We're in the same space. We can develop the same thing for our own personal investments. So I hope you loved it, and really happy to see you guys again.
Okay. Thank you very much, Sammarieo. And here's an opportunity, guys, to ask your questions, if it is that you have any, because, you know, while he has shown us how it is that we can use AI in predicting how the market behaves, we can definitely see where it's applicable, as is said before, you know, in other areas of sphere. As long as you simply train the model, feed the model with the relevant information so that the model can learn and then essentially do the work for you. Because as long as the computer is able to now decode all of this information, remove all of the junk from it, you know, the missing data, the data that skews the prediction and so on, you essentially, you can now recognize certain trends that will happen in the market before it happens, and essentially protect your money in this case. Or if it is that you'd want to create an AI solution that predicts how it is that, let's say, a spaceship will go up to the moon, you know, based on the design of it or the materials that are made in it, that is made from, whether or not that spaceship will crash or not. The AI can essentially work on in any sphere, as you said. And as long as it is that we train the AI, we understand the domain knowledge that is involved in the preparation of the AI, what it is that we want it to do, and how it is that we want it to behave under certain situations. So as I know we had asked some questions earlier, but if there's any further questions, now is an opportunity to let your voice be heard. You can raise your hand, you can write in the chat. O'Shane, how are we on YouTube? Any questions from that side?
I'm going to check. Also, in the meantime, I do have a poll that I want to launch to get a feel of everyone like area of expertise or level in terms of AI. So for those, if there's any additional questions, you guys can ask, but I'm going to launch a poll in the meantime.
Okay, thanks, O'Shane. Horatio, you can go ahead and unmute.
Hello, I was just curious about a little knowledge earlier when you enlightened us about using pandas versus NumPy. And I was wondering if pandas can also import like spreadsheets from Microsoft Excel.
Yes, it can.
It can.
So pandas come with a out of the box tool or function to import CSV file, Excel file, and even SQL file. So yeah, it can. I think with NumPy, you have to import a Python library to do so. But of course, some might have more you definitely have more experience than me using NumPy. So some is there like inbuilt built-in function for NumPy to import CSV, or that's just with pandas?
So I know sure with pandas there's an inbuilt function already to import Excel, but I can't speak for NumPy. I don't think so, because what I really use NumPy, and most persons to use NumPy for, is to just to do calculations. But once you get the data in pandas data frame from Excel, you can use NumPy to do all your calculations at that data frame.
Okay, so can it be a companion to Excel, an active companion? So rather than to take something that Excel has already finished with, like a final product, and then transfer it, and then let NumPy and the IDE take it over fully, can it interact like an active companion with both of them running in tandem? That means that, like, if you use an add-on to do certain calculations, like the solver to solve equations on the Excel, can you do that?
Absolutely, yes, you can.
Interesting. Okay.
Recently just launched a new integration now where you can actually use Python in your Excel. So if you update your Excel with your latest version, you can actually use Python in the game.
Okay. Thank you. That was I need to know. All right.
All right. There's a question from YouTube. How likely is it that these cool smart apps may enable an early investor / machine learning a practitioner can seek to gain using said apps? If so, what are some apps and what are failure / success margin? Interesting. Not sure if I fully understood that question.
Yeah, same.
Well, from what I read, it sounded as though they wanted to have some amount of confidence as to what are some of the tools that we see, and we see evidence of this tool being used and making a difference in how someone gains some money or lose some money, given that you're early investor. That's what I got from the question.
in that case, then I can speak on it a little. Well, LLMs, those are some. So, for example, LangChain. A lot of persons are using LangChain and OpenAI and all of these other large language models to incorporate with their company and their data. So, how a lot of companies are using these systems now, especially LangChain, if you have some data set or you have large data sets, unstructured data in your company, you can simply have this data pass into a database, a vector store, and be able to query and ask anything about your company data just by interacting with a chatbot. So there are lots of other tools, other persons are developing these AI systems to do tasks just like that. So in terms of validating and margin, I'm not sure if I understand that part of the question, but there are a lot of companies incorporating AI tools in their workflows and their businesses right now as they speak.
Right. And for a new practitioner, you know, or new investor, the reality is that there's going to be some, for lack of a better word, dumb tax that need to be paid. So essentially, the area in which that you'd want to use this AI knowledge, you have to have some amount of appreciation as it relates to, you know, market trends, what are happening, so that you could actually use the tool properly, because the machine is essentially using data to make predictions. However, if it is that you have not trained the machine properly, it won't give you as accurate of a data as a prediction as you'd like. And if it is that you're not familiar with the domain in terms of one of the things that you explained was about, you know, when the market is open versus closed. If it is that you have not trained the model in such a way that you could predict that the market will actually be closed, and it's best to sell your stocks before the market gets closed so that you can make a profit. If it is that you don't really truly understand certain fundamentals, some of that dumb taxes that you have to pay, then this tool won't work for you. Unfortunately, the AI tool will not work for you.
Right. You come back again to having certain level of domain knowledge or experience in the field that you probably want to invest in or develop some AI model for. Again, if you can, as an AI expert, you can go into a medical field and develop a system fully fledged for medical practitioners. You have to have some level of knowledge in that specific field. So it goes right across the board. I think Tara has her hand up for a while.
Yes, I was actually gonna go over to Tara. Tara, go ahead, please.
Hi, another question. So in the models, we took account for historical data from the company, right? And we looked on the price, mainly the quantitative aspect. So what I wanted to know was, are there any qualitative aspects of the company historically that this model incorporates? For instance, can we see management quality change in the board, corporate governance, that type of thing?
Well, qualitative data, when I think about qualitative data, the first thing I think about is like textual data, right?
Yeah.
And first thing that comes, for example, working with an annual financial statement, and you might see these information presented in the financial statements where they had some board meetings, we have new changes, and then you have the numerical aspect for that annual statement where from 2020, we see where there's an increase in revenue or some aspect of the financial statement. And we can train ML model to, well, one, find correlation. So get those texts, convert them to embeddings or some quantitative aspect, get some sense. Well, is a change in management members or board or directors actively or directly influencing the performance? So I think it's certainly, I believe it's possible, and I won't be shocked, or it's not far-fetched for someone implementing a system or a model to do that particular thing.
Okay, thanks.
Good question, Tara. Any more questions? All right.
Well, this is kind of off track. But considering that we have an AI hackathon coming up, and of course, this is us asking you, Sammarieo, like what are some like ideas someone could, generate from your presentation to, look forward to building something in that AI hackathon. And then secondly, for those who are like want to brush up on their algorithmic trading background, what also do you have any resources that you could share?
So resources, certainly. So most of my knowledge is self-taught. I read a lot of books, watch a lot of YouTube videos. In terms of books, there are a lot of books out there. From just Google algorithmic trading with Python, you're going to see a lot of books. Financial machine learning, that's also a really good book. I think you can check out that one. It has a GitHub with a lot of practical guides into how you can develop strategies. So GitHub is there. Books, definitely check out a lot of books, and YouTube. In terms of generating an idea from what I presented today, one idea you could come up with is probably a reinforcement learning agent that learns from buying and selling and maximizing its reward, and look for certain, I would say, patterns in the market to know when to buy and when to sell that can maximize their return. So I think that would be a really cool and fun project. I would be excited to see. So again, reinforcement learning agent that buys a particular stock at the appropriate time.
Okay, all right. Thank you, Sammarieo. Arden?
Yes, thanks, Shane. Thanks, Sammarieo. And thank you guys for your questions. All right. So earlier, I was actually having some challenge with my computer, and it brought up this, it brought up the poster before I was even ready. But here it is, guys. So essentially, we have a poster competition right now. And you would need to submit your if it is that you're interested in entering, you need to submit your photos, your poster by August 31st. So it's not a lot of time left, but I'm sure you guys are all talented individuals able to create some beautiful masterpiece. Who knows, maybe even based on some of the AI workshops that we've done already, maybe there's something that you've learned and you recognize it, you could incorporate AI in this ability to create some poster. By all means, the floor is open. The guidelines are here. The only thing that you need to do is simply follow the guidelines and submit your email, submit your posters to info@caribbean.dev. Now, of course, the prizes actually have been updated. The first place is still $15,000, but the second place has been bumped up to $10,000, and we're going to have a third place winner of $5,000. So if it is that you want a little extra cash, if it is that you'd want to, explore your creative skills, whether it is that you're a digital media professional, whether it is that you're just simply fond of Photoshop and creating it and using this tool to enable or solve problems, by all means, feel free to enter. The competition details are here. So additionally, if the computer will behave, we're going to just, of course, thank our sponsors. So we have OSUB, we have Jamaica Artificial Intelligence Association, and we, of course, want to thank Jamaica Developers Community. All right, so these are our sponsors, and Caribbean Tech Connect. Now, if it is that you would want to join our community, here is how you can join our community. Our spaces are available. It is an opportunity for us to learn and grow together, and be a part of a game-changing group where we're seeing where it is that we can make a change in the society, move the Caribbean, move Jamaica from mainly a consumer of technology to a producer of technology. So here's what. this is a great community to join and have fun, grow, and essentially change the world. Now, I'd like to thank Sammarieo, or as we've already said, our sponsors, and of course, you guys for joining us. Let me know, however, and we have Sammarieo dropping in some details in the chat for you to be able to reach out to him. He has given you a cell number as well as an email address. So feel free to communicate with Sammarieo directly if it is that you do want to have some more knowledge on using AI in trading. And of course, we have a communication from Matthew Stone giving us a link to his community, Jamaica Artificial Intelligence Association. Okay.
Yeah, let me just say one thing before you end.
Sure, go ahead.
Yeah, so yeah, thanks everyone for coming out. I'm very encouraged by the participation. Great presentation from Sammarieo. Yeah, I think it's very good that we have presentations like this because it's going to help with raising awareness of the AI talent that we have in Jamaica. And I'm hoping y'all take something from this and hopefully create AI solutions of your own, or even if it helps with just kind of giving you an interest with the field. I would very much encourage you guys to just take a step into it. It's a very fruitful endeavor. You'll definitely learn a lot, especially right now where essentially everything is powered by AI. Definitely a good time to really get familiar with what's out there. And we'll be having a lot more workshops like this, even past the hackathon, where you guys will be able to learn more about AI. So just look for that. All right, over to you, Ali.
Thank you very much, Matthew. And of course, once it is that you join the community, you definitely get all the updates as it relates to the events that are coming up, competitions that we've had, and competitions that we're gonna be having, which including, of course, the AI hackathon, this poster competition in preparation for the cybersecurity month coming up, and other competitions that we'll be having, and opportunities for you guys to get involved, share your talents, grow, rub shoulders with some AI practitioners, rub shoulders with some developers, rub shoulders with some quality assurance persons. And we see where Shane has posted the link in the chat. So if it is that you weren't aware of how to get to us, the link is in the chat. We also have, of course, our YouTube information also in the chat. So you can, of course, if it is that you joined late, if it is that there were some past videos that you didn't get a chance to watch, you can always rewatch, enjoy, growing your knowledge, and even share with a friend. Share with a friend who may be interested in computer science and not sure what area to go in. We've done a lot of different programs, career day, workshop, AI workshops. So by all means, check out the content, have fun, grow with us. We're definitely happy to have you. And I think that is it. So if there's any questions, of course, please reach out to us, send us an email. You have our contact details in the chat, save it, and connect with us. Have fun, guys. Have a great evening. Blessings.
All right, take care, everyone.